The students set chairs in 24 rows with 8 chairs per row. The fifth graders from School 87 were preparing for Parents' Night. How many people can be seated? Lots of numbers in this one. Here we have 24, 8, I see fifth, 87. Wow, that's a lot of numbers in this problem. We're going to need to find out what those numbers stand for. 24 is referring to the rows. The 8 is the number of chairs in each of the rows. The fifth is talking about the fifth graders. And 87 is the name of the school, School 87. So I don't think it's a long addition problem. There are too many categories floating around in this thing. The chairs in the 24 rows and the 8 chairs per row is in the same sentence. You can see that this whole sentence includes the two numbers that we were talking about. And this particular sentence has the fifth graders, but that's just really the name of the grade. And this one is the name of the school. So neither of these numbers make a whole lot of difference to the problem itself. A lot of times, the numbers that are really important in a story problem are included in the same sentence structure. And here we have an example of that. Now, the word that talks about the operation here would probably be rows. And we also have another clue word when they talk about set, a set of chairs. So both of those point to either a multiplication or a division application. So let's see how this problem might be set up. Okay, so we're focusing on 24 and the number 8 with the idea that we have sets, a set of chairs, and also rows. Would we expect, if we have rows of 24 rows with 8 chairs per row, oh, that's another, I didn't even see that one until now. I need another sticky for that because it's per. Which gives us much more of an indication that it is a multiplication problem. So here we have our thinking. Would we need a larger number? Multiplication is going to give us a large answer. If we have 24 rows of chairs with 8 in each row, that would probably give us a larger number than either the 24 or the 8. So at this point, we're going to use multiplication. Now, it takes a long time for me to explain this. The thinking process is very quick. It happens very, very fast in your child's head. The explanation, I'm trying to tell you what you're looking for. That's the thinking process. But after your child gets used to thinking in this way, the brain will just go through the different options very, very quickly. So here we have our multiplication problem. The reason that we're thinking multiplication is are the sets, rows, and per clues that we've got in here. All right, 8 times 4 is 32. I'm going to put down the 2, and I'm going to carry the 3 to the next column. 8 times 2 is 16, 17, 18, 19. So we have 192 people could be seated. People. 192 is definitely larger than either of our other numbers. So we're going to be, it makes a whole lot of sense to have multiplied those numbers. Your child may actually do the multiplication a little bit differently. 24 times 8 this could be broken down into 20 plus 4 and multiplied by the 8. So we would have 8 times 4 is 32, and 8 times 20 would be 160, because 8 times 2 is 16, and then we're going to put the 0 on the end of it because we're in the hundreds column. These two smaller parts could be added together then to give you the 192 that we got the other way. And this is more along the lines of how your child might multiply via Common Core.